Okay, here we go with the solutions to the kinetic energy worked examples. And we're starting on page 51. So what is the kinetic energy of a 90 kilogram rugby player running at 4 meters per second? So kinetic energy EK is equal to half mv squared, 0.5 times 90 times 4 squared. One of the biggest mistakes that people make with these calculations is they forget to square the velocity. So please don't. So this will give us 720 joules. Question 2, what is the velocity? So calculate velocity of a 250 kilogram motorbike with 112.5 kilojoules of kinetic energy. So to calculate velocity, now we have our formula down here, but I'm going to go through the rearrangement of this just because it's a bit of a trickier one. So we'll start with EK is equal to half mv squared. Take the half m and cross multiply that down, so we're left with v squared is equal to EK over half m, which will then give us v is equal to EK over half m and the square root of all of that. So to find velocity, square root of EK over half m, which gives us now 112.5 kilojoules. I'm just going to do 112.5 times 10 to the power of 3 divided by half times 250. Don't forget to square root it. And that will give us 30 meters per second. But just a word, when you're doing this in the calculator, it's possible to do this all in one. So just start from left to right and work through the equation. So we'll open up square root first, then we're going to have 112.5 times 10 to the power of 3, get it in a fraction, and then beneath you can do 0.5 times 250, you'll get 30. Okay. Calculate mass of an object which has a kinetic energy of 400 joules and a velocity of mass 20. So again, if we're starting with EK is equal to half mv squared, to work out mass, leave mass where it is, pull the half and the v squared down, so EK over a half v squared. So we'll have 400 joules divided by half times 20, and please do not forget to square the velocity, and that will give us 2 kilograms. So a lorry of mass is moving at a constant velocity. It's the kinetic energy of this. How fast is it traveling? Okay, so we can just use velocity, so v is EK over half m. Square root of that. So we have 150,000 joules over half times 3,000. And that will give us 10 meters per second. Okay, question 5. Car has a kinetic energy of 200,000 joules when travelling at a velocity of 20 meters per second. What is the mass of the car? So calculate mass. Mass is EK over a half V squared. 200,000 over half times 20 squared. That will give us 1,000 kilograms. And lastly, question 6. A model race car has a mass of 10 kilograms travelling on a circuit with a constant velocity. If it has kinetic energy of 3,125 joules, how fast is it travelling? So we're looking for velocity again. V is equal to the square root of EK over half M. We get 3,125, a half times 10, and the square root of that, and that will give us 25 meters per second, which is a rather quick model race car. If we're looking at the velocity of that, we're talking about 60 miles an hour, so I don't quite know whether that's particularly accurate or not. Okay, well, thanks for watching, and any questions, just get in touch. Okay, bye now.